Hello everyone. In this video, I'll discuss about the rank correlation. Basically, concern is to discuss a problem solving about the two cases with that topic. One is when we don't find any tie, that means there is no repetition, how to solve it. And the second case I will take up with the example that what to do when we have a repeated entries. So that is called a repeated rank or a tied rank. So let us see what does it mean. What do we mean by this rank correlation? Basically, it measure how closely two sets of ranking agree with each other. And even if you have a group of individual rank according to two different characteristics, then also it can be implemented. It also discusses the degree of relationship between the rank given in the for example for the same individual but for two attribute, there also it can be implemented. Apart from that, if let's say two data is given and they are expressed in the ordinal form, that means in order, then also we can find the correlation between them. So it is denoted either by RS or by this symbol rho. So the first case is that when we don't have any repeated entry and we have to assign a rank first. So in that case, the rank correlation coefficient formula is used where we have a 1 minus 6 times summation of d square upon n square minus 1, where this n is a number of pairs and d is the difference between two rank of each individual. So before that, ranking is required and then we can find a difference. So let us see with the help of one example. Here I have taken an example where 10 recruits, they were subjected to first selection test before for the suitability of certain course of training, and at the end of the training they also given a proficiency test. So when the marks of two exams turn up, one is for the selection test taken as a symbol X and the second one is a proficiency test taken as a Y. So these two marks for the 10 recruits are there and we are supposed to find a rank correlation coefficient between X and Y. First of all, we will see that what is a step number one. Since we observed that there is no repeated entry in X and Y, so ranking part is the step number one. So you will see the basically there are only three steps: ranking, difference, and the evaluation part. So first step is how do we do ranking? We can give rank in a ascending or descending order. Both will serve the purpose. So we can assign 1, 2, 3 ranking. So let's say when we want to begin with this X variable first. So ranking I have decided in this question in the increasing order. That means I will give a 1 to the lowest entry. So here in this X data I have a 10 as a rank lowest entry, so I'll give a rank 1 to it, and then second 12 2, 13 will get 3, then we have a 14 will get a rank 4, 15 will get rank 5, after 15 there is a 16, so 6, then 17 7, after 17 we have 20, so it will be 8, then 22 is 9, and the last one is 24, which is 10. So we got a 1 to 10 ranking for the X. In the same manner we can assign rank to Y. Y also have no repeated rank. So the first one is 31, after 30 we have a 33 rank 2, then 34 3, 35 4, then we have a 38, that is going to be rank number 5, then 39 6, after 39 we have 40, that is 7, then 8 42, 45 is 9, and 46 is 10. So in this manner we have assigned a rank to it. So that is the first step. Sometimes the direct ranking is given, we can proceed the question from here, but in this case the data entry is given. First we will do the ranking part. Now after ranking, the next step is to find a difference. So we are going to find a difference for that. So in a difference, what we do, we have to take a difference of Rx, and means we will find out a difference of any. It can be done in both way. The difference will be 0. This is minus 3, minus 7, minus 3, 1, 3. Next is 3, 0, 3, and 3. And what we need to do is, while we doing this rank correlation step, so this is one of the very important step to check whether the ranking is done right or not. We just have to add the d values. If I'm getting an answer 0, it means the ranking is done right. So we are observing all the negative values minus 7, minus 3, and minus 3 is minus 13. And here 3 fours are 12 plus 1 13. So yes, we get answer 0. So that is a one of the very important point to check. And after that what we need to do is we just have to take a square. So when we take a square of 3, it's 9, then 49, 9, 199,099. So when we take a square of all the individual differences and add it, we get a 104 as a sum. Now we are ready with the last step, which is implementing the values in the formula to get a rank correlation. So we observed that this is the value of n is 10 here, and summation of d square is 104. So when we put it into the formula, we are getting this expression after simplification, that is 0.6303, and when we take a difference we observed 0.37, which is positive. So there is a positive correlation, but the correlation is weak to moderate. So we can say that the association between the selection test marks and proficiency test marks secured by recruit is moderate or weak to moderate. So that is an interpretation. So now next one is we are going to take up a situation where we will see that some entry might be repeated. So it will put into the category of a repeated rank, or we can also call it a tied rank. So formula is same like that, but only there is an extra entry here in the formula, previous formula. Everything is same, but when we are doing the calculation work, we observed along with summation of d square, there is some term added, and here mi is a count of the repeated rank. So when we will implement it, we'll get an idea. Rest are the same values, and where this term which we are adding with the dx square sum, that is actually known as a correction factor in the both variable. If both are having a repeated entry, so automatically they will get some value, and they are the adjusting factor, we can say, because due to the average ranking there must be a loss of variability due to the tie, so it can be managed by adding this term. So let us see with the help of example. My second example, here I have taken the 12 father's height and the eldest son height, which is y, and father's height is x. Both are in inches. So we have this height here, and we want to ask a question is about the rank correlation, obviously the Spearman's rank correlation. So how we are going to implement it, let us see. And we can observe that here the values are repeated. Here we observed that which one, 67 is repeated, then 68 is repeated, here also 68 is repeated, right? And other terms are there. So but before solving it, let us see what are the major steps. So you will observe that the difference between the no tie and repeated case, the ranking part is only the different, and rest is same like the previous question. Why? Because first of all, before jumping over to ranking, we need to identify what are the repeated terms, and so that we should highlight it, and then we can decide whether to give a rank in a ascending order or in a descending order. So after that, ranking can be started. The main point is this, the fourth one in my slide, where I have written that if there is a repeated values or a tie, so what we are going to do, we are going to assign a average rank. Now average rank to those value means what? Let's say there are two terms, and while assigning the ranking, the term which are repeating is at the fourth and fifth stage. So fourth and fifth ranking need to be averaged. So 4 plus 5 average is 4.5. Let's say in the same manner, if we have a three terms which are repeating and they are coming at the uh, value of 4, 5, 6. So when it is a fourth, fifth, sixth term, so how to rank them? So we can take an average of 4, 5, 6 is 5. So fourth entry, fifth entry and sixth entry, which are same, will be given the similar rank. So let us see, we will identify when question will be considered. So first step is we have to identify that what are the repeated entries. So here in X I observe 67 is repeating two times, and 68 is also repeating two times, and apart from that there is no repetition in X. And for Y there is a 68 one more 68, third 68, and fourth. So there are 468 in the Y data, and there is also a sixth 66 term, and one more term we observe, that 65. So there are three observations at a different count which are repeating. So the moment we identified, it will be easy for us to do the question. So after identifying the repeated entry, let us start with the step number 1 of the ranking. So here in this question, I am going to assign in the ascending order. So first I will start with the x variable. In a x variable, the lowest value is 62, so rank is 1. Next, rank 2 for the 63. After 63, we have a 64, which is a third rank. Just a minute. This is a third. Then 65 is fourth, 66 is fifth. Now after 66 we have a 67 and 67 two times. So it means at a 6th and 7th position we got a similar entry. So we need to give the average rank to them. So 6th and 7th will be given a 6.5 because we will get a 13 by 2, which is 6.5. So it means we are going to assign an average rank to the repeated entry. So there were two, so 6.5, 6th, 7th position. Now 6th and 7th got average. After that it is an 8. So after 67 I am again getting the repeated entry, and that is coming at 8th and 9th stage. So 8 and 9 average will be 8.5. Right, we are getting a 17 by 2, so it will be 8.5. So 8.5 here and 8.5 here. So after 8th and 9th, we have a 10th count, and when we see what is the next value is 69, which is a 10th number. Then we have a 11th as a 17 and 12 as a 71. So we have assigned this X series. In the same manner, we can begin with the Y. Since my X data is being assigned as a ranking in the increasing manner or ascending order, so I'm going to apply the same strategy for the Y. So here when we look into the Y value, the lowest Y value is 65, and this is a repeated one because already highlighted with a different color to get a idea. So 65 is coming at a first and second position. So average of 1 and 2 is equals to 1.5. So 65, both 65 will be given a 1.5 rank. Now first and second is adjusted. Next value is 66, that is also repeated, and that is coming at third and fourth count. So third and fourth rank will be adjusted, which will be a 7 by 2, and 7 by 2 is equals to 3.5. So we are going to assign 3.5 to 66. So next turn is for the 5, and after 66 there is a 67 and the rank is 5 here. So it is not repeated. So single rank after 67. Now again we are going to get a repeated rank, and that is coming at 6 because there are 4 numbers. 1, 2, 3, 4. So it means I stopped at 5, next rank is 6th, then 7th, 8th and 9th. Since both are of all the 4 are same entry, so we will average it, and when we average, the sum of this is 30 by 4. So 30 by 4 is equals to 7.5. So we are going to assign 7.5 to all the 68 entries. So 7.5, 7.5, here also 7.5, 7.5. That means 6th, 7th, 8th and 9th positioned entry got a average rank, and all were got 7.5. So it means till 9th everything is adjusted. After 9th it is a turn for the 10th. So 10th number is 69, which is single, and then 70, which become 11th entry, and 12th. So by highlighting it will be easy to identify how many times we have to get an average. So this is a step which is different from the previous question where there was no repeat. In a repeated we average the rank. So this part is different from the previous question, and now we will move ahead with the same criteria. What is that? The second step is we need to find the difference of individual ranking, and then we find its square. But for the checking, we will see the difference must be 0. So when we take a difference here, we got a first difference 4 minus 7.5 is minus 3.5. Next is 2 minus 3.5 minus 1.5. 6.5 minus 7.5 is minus 1. 3 minus 1.5 is 1.5. 8.5 minus 10 is minus 1.5. 1 minus 3.5 is minus 2.5. 11 minus 7.5, 3.5. 5 minus 1.5 is 3.5. 8.5 minus 12 is minus 3.5. 6.5 minus 5 is 1.5, and then 10 minus 7.5 is 2.5. 12 minus 11 is 1. So we have calculated all the d. When we added all the terms, and we get an answer 0. So I have checked it. You can also cross check that answer must be 0. The next step is to square the entries. So when 3.5 will be negative will be squared, we are getting 12.25. 2.25, next 1, 2.25, 2.25, 6.25, next square is 12.25, 12.25, wherever there is 3.5 it is 12.25, 1.5 is 2.25, 2.5 is 6.25, and 1 square is 1. And after adding all the terms, we are getting 72.5. So we got the d square. Now since in this case we have to calculate this part, which is also important, which is a correction factor. So for the correction factor, first of all, let us identify once again, looking into the question, that how many repeated ranks were assigned. So first let us look into x. So we got a one case where there is a 2 repeated ranking, so I'm writing here m1 value as a 2. Then 68 is also repeating 2 times, so m2 is 2. This is done with the x series. Y series has 3 cases. The first case is I got a double entries, which is 65, and then 66 also double entries, which is 2, and then we faced a 68, which is 4 in count. So these m1, m2, m3, m4, m5 were the 5 instances for both x and y where we get a repeated rank. Now that will help us to find a correction factor. So this is a formula for finding a correction factor, taking a sum of mi m square minus 1 upon 12, and even if you want to simplify in the numerator, it can be rewritten in this form. So we are going to plug in 1 times all the value and add up all. So since 4 values are 2, 2, 2, and last one is 4, so when we cube the 2 it is 8, and 8 minus 2 is 6. So all the numerator are getting 6 for the first 4 term. The fifth one is 4, so when you take a cube of 4 it is 64, minus 4 is 60. So we got a 6 by 12, 6 by 12 as in half, half, 4 halves, and then 60 by 12 is 5. So adding all the terms, we are getting 7. Here we are getting 7, right? So this is our correction value for total correction value, or for all x and y. And then we are now ready with all the entries required for finding a rank correlation. N is 12 here, summation d square is 72.5, and the correction factor required is 7. So when we plug in all the values here, and after simplification of this term, 6 into 72.5 plus 7 upon 12 into 143. So when we simplify this term, we are getting this expression as a 0.278, but 1 minus 0.27 is 8 is coming out to be a 0.722. So it is positive correlated, and since 0.7 is a strong correlation value, so we can say there is a strong positive association between the father and their son height. That means we agree upon the notion that taller father generally have a taller son. So I hope with these two examples you got an idea how to deal with the rank correlation, means Spearman's rank correlation. And this is also one, we can say, the scale of the interpretation. There might be sometimes little difference from point to point, but usually it can be considered. So I hope you understood the concept. Thank you for watching.